This is a video for the topic of lecture for this week. The first topic is logical reasoning. Okay, so in this topic we're gonna learn to demonstrate the basic knowledge of statements and argument, and we're also gonna demonstrate the understanding of statements and argument. We will apply the understanding of deductive argument and inductive argument to perform the simple task and apply the appropriate knowledge and skill of logical reasoning in the context of simple and complex routine in problem solving. Okay, what is statement? Statement is actually a sentence of which truth value can be determined. So what is the meaning of truth value? We can say whether the statement here is true or false. So either the statement is a true statement or false statement, but we cannot say it is both true and false statement. Only one of them, whether true statement or false statement. Okay, for instance, we see here 4 plus 4 equal to 8. It is true, right? So we call it as true statement. 4 plus 7 equal to 8. No, false, right? Because 4 plus 7 you're gonna get equal to 11. So that's why we call it as false statement. So still these two is still a statement. Okay, now let's say we go through a few examples here. First one is a question. How do you come to school? The next one is exclamation. That means we ask or we ask the person what to do. So please send the workbook. And the next one, a command, watch out for the car. So basically all of these three are not a statement because we cannot say or we cannot determine the truth value from these three statements. Okay, so here, what about the next example? X plus 3 equal to 5. Can we say it as a statement? No, because we don't know what is the value of x here. So that's why we are not sure whether it is a true statement or false statement. So that's why we can say it is not a statement. Okay, now go to the example. The question here asks you to determine whether the following statements are true or false. If it is false, prove it. So first of all, obviously we can see the answer here, right? So but still we need to show the solution. How do we determine whether it is true or false? First, we have these two statements here, first one and the second one. First one is x plus y to the power of square and to the power of 2 and we have another one which is x squared plus 2xy minus y squared. So we want to know whether this is true or false, which means this value is equal to this value or not. So what we can do is here, first of all, we let x equal to 2, y equal to 2, and then substitute inside the first one here. So you substitute 2 plus 3, you're gonna get, here y is equal to 3. So 2 plus 3, you're gonna get 5. And then the next one, you substitute also 2 squared plus 2xy, which is 2 times 2 times 3 minus with 3 squared, you're going to get equal to 7. So basically here you got 5, and this part, the next part you got 7, right? So 5 equal to 7. True or false? False statement, right? So that's why here, if you they ask you to determine whether the following statement are true or false, your answer is false. Why? Because x plus y squared is not equal to x squared plus 2xy minus y squared. Okay, the next example. Determine whether the following mathematics statements are true or false. So, all polygons have diagonals. False, because triangles do not have diagonal. Some perfect square are whole number. Is it true or false? Some perfect square. It is a false. Why? Because all perfect square are a whole number. Do you know what is perfect square? Perfect square is the square root of a number which is, okay, basically perfect square are the non-negative integers which is positive integer that result from multiplying an integer itself. So for example, we have 1, we have 4, we have 9, we have 16, we have 25. And here if we square root this value, 1, square root 4, square root 9, square root 16, what we're going to get is 1. And then answer 2, here 3, we get 4, right? So basically all of them are whole number, all of them. So that's why the statement here is false. Then the next one, all even number have prime factor. The answer is true because all the even number greater than 2 have at least one prime factor, which is 2, or we can say it is true that all even number have prime factor. So we give example, let's say 6. 6 is consists of 2 times with 3. And then 8 is equal to 2 times with 2 times with 2. So all of these are prime number, right? Let's say give another example. 10 equal to 2 times with 5. So this is prime number, this is prime number. So we can say here all even number have prime factor. Okay, the next one, negate statement. So basically we're going to use the word no or not to negate a statement, to make the statement a negative statement. So to the negation of statement P is written as like this. So let's say we have P, which is true statement. We want to make it as a false statement. So we put it a tilde, this symbol in front. So it is called as the negation of P. So let's say this P is true. Then if we want to negate the statement, that means we want to make it as false statement. Let's say if P here is false, then if we want to negate, then we're going to make the value after negation is a true statement. Okay. Give you example, form a negation for each of the following statement using the word no or not. So the first example here, 12 is a multiple of 5. So if we want to negate the statement, we will just write 12 is not a multiple of 5. What about the second example? 41 is a prime number. If we want to make it a negation, just change it into 45 is not a prime number. What about the next statement? All multiple of 5 are multiple of 10. So we just add not. All multiple of 5 are multiple of 10. What about the next one? 0.4 is equal to 400. 0.4 meter is equal to 400 mm. If you want to negate the statement, 0.4 is not equal to 400 mm. Doesn't matter whether it is true or false. Here what we do is we just negate, make the we just turn the statement into negative statement. Okay, the truth value of a compound statement. A compound statement here is actually a combination of two or more statements by using the word and or. And or. So let's say the word and in mathematical statement means both. The word or in mathematical statement means one of them or both. It can be two possibility. Okay. The first, we're going to go through example. What we're going to do is we combine the following statement, which is P and Q, which are given here, using the words and using the word or. So, first, a pentagon has 2 diagonal and heptagon has 4 diagonal. If we want to combine statement using and, so what we're going to do is we have the first statement here, right? The P, and we have Q. So a pentagon has 2 diagonal, which is P, and heptagon has 4 diagonals, which is this one is Q. Settle for and statement. Now we want to create for or statement. So a pentagon has 2 diagonal, which is P here, or a heptagon has 4 diagonals, which is Q here. So we combine using and or. Also the same for the next question. We have P and we have Q. We combine with and or. Okay, now the next example. Determine the two statement P and Q here in the following compound statement. So we have this, and this P 9 and 91 are prime numbers. So the first question, we have 5 plus 3 greater than 5 and 5 minus 3 less than 5. So basically this is our first statement, P and Q. So just determine which one is P, which one is Q, right? So the first one is P, the next one is Q. Then the next question, we have 9 and 91 are prime number. So separate it into P and Q. So P, we have 9 is a prime number, settle. Q is a prime, Q equal to 91 is a prime number. Okay. Okay, now we're gonna go through implication of if P then Q. So a statement if P then Q here is known as the implication, where P is our antecedent, Q is our consequence. Okay, now we're going to go through construct a statement in the form of implication if P then Q. Okay, the example here, form an implication if P then Q with the given antecedent and consequence. So we have antecedent, we have consequence. So basically antecedent is our P, consequence is our Q. So we have our statement here, right? This statement and this statement. So we just want to form an implication of if P then Q. So what we need to do is, if the statement P here, K is divisible by 5, then K is multiple of 5. So we just put if and then put the statement P here, then put the statement Q, which is this one. Also the same for the next question, we have antecedent, which is P here. So P, this one is our Q. So put inside this implication if P then Q. So you get if set K is a subset of L, which is our P, and then NK less than or equal to NL. So this is P, this is Q, just like that. Okay, now implication P if and only if Q. Okay, so an implication P if and only if Q consists of these following two implications, which is the first one, if P then Q, if Q then P. So from this we combine, we can get P if and only if Q. So how to form implication P if and only if Q with the following implication? So let's go through the example. We have the first one, if K is a prime number, then K has two factors. So basically if P then Q here. So our P, and the next one, if K has only two factors, which is our Q, then K is a prime number, which is our P. So here you can see, right, we have our P and Q statement, which is P, K is a prime number. What about Q? Q is K has only two factors. So now we just want to create the implication P if and only if Q. So we have P, which is our K is a prime number. You already put it here, if and only if. Then here put Q, K has only two factors. Okay, now the next one. Construct and compare the truth value of a converse, inverse and contrapositive of an implication. So basically, if you have a statement which is if P then Q, here we have if Ali is a prefect, so which is our P, then Ali is a disciplined person, this is our Q. Then P is Ali is a prefect. Q is Ali is a disciplined person. So this is our P and Q for now, the statement. Okay, now from this statement we want to create a converse. So what we need to do to convert to converse, we need to write as if Q then P. So here we put if, and then here is our Q, then this one is our P. So just copy lah. Ali is a prefect. If Ali is a disciplined person, then Ali is a prefect. And now we want to create for inverse. So for inverse, how to create inverse? We have if the negation of P, then negation of Q. So remember negation, it is a negative statement, a negate statement for a sentence, a statement. So now since P is equal to Ali is prefect, so that means here for this one, if Ali is not a prefect, then Ali is not a disciplined person. What about contrapositive? What we can create is, we will use negate statement also, but we change P and Q, just like when we change for converse here. So if Ali is not a disciplined person, then Ali is not a prefect. That is how we create it. Okay, now we're gonna go through another example. What they want us to do here, we write a converse, inverse, and contrapositive based on this statement. So we have if x is a positive number, then x is greater than 0. So basically here is our P, x is greater than 0 is our Q. So now this is our statement, right? To create the converse, we follow again if Q then P. So if this one Q, then this one P. So you see they changed position. If you want to create the inverse, if negate Q, then if negate P, then negate Q. So this is positive number, right? X is a positive number. So if you want to negate it, just put is not. If you want to negate the Q statement, X is not greater. So that's why you can use like this. Also the same for contrapositive, we just change the position for negate Q and negate P. So here if negate Q, then negate P. So that's why you write. Oh, sorry. Okay, now if we want to know the truth value for the statement just now, so let's say your P is equal to true and Q is true, then statement will be true, converse will be true, inverse will be true, contrapositive also going to be true. What about when P is true, Q is false, statement is false, converse it is true. For inverse it is true, but contrapositive it will be false. If P is false and Q is true, the statement will be true, converse will be false, inverse false, and then contrapositive true. The next one, when P and Q are false, the statement is true, converse also true, and inverse and contrapositive also true. Okay, now let's go through the example. Determine the truth value of the statement for converse and inverse. For the contrapositive of implication, if 2 times 3 equal to 6, then 8 minus 2 is equal to, times with 3 is 18. So now, we have if 2 times 3 equal to 6, right? So this is basically our P. We have Q is equal to 8 minus 2 times 3 equal to 18. So here, calculate, check first. P, which is our antecedent and our consequence. So P 2 times 3 equal to 6, true or false? It is true. So now 8 minus 2 times 3. So 2 times 3 is equal to 6, right? This one, 6, 8 minus 6, it is equal to 2. So basically this answer is false. So now your statement here, it is true, this one is false. So to know the truth value is this statement, right? If P is true and Q is false, it is false. How to know? Oh, sorry. This one, go to the statement. If it is P is true, Q is false, then here it is false. So now for the converse, it will be true. For the inverse, it will be true. For the contrapositive, it will be false. So this is the answer. Okay. Okay, the next one, we want to determine the counter example to negate the truth of a particular statement. Okay, for a false statement, at least one counter example can be given to negate the truth of the statement. That means we can give one of the reason why this is false. So let's say all polygon have two or more diagonal is false because triangle does not have diagonal. Okay, triangle is the counter example to support the false value. So basically, we just give a statement to support why we state that this statement is false statement. Okay, one example we can go through is here. Determine the truth value of the following mathematical statement. If it is false, give one counter example. Okay, first one. Sum of interior angle for all polygon is 180. This one is wrong because let's say you have a triangle, right? Inside, obviously, you're going to get 100 degree for the interior angles. Which means, let's say this one plus this one plus this one, you're going to get 150. But let's say you have square of all of this. If we add all of the sum of the interior angle, you're going to get 360 degree. Also, that's why here, if you want to state whether it is true or false, obviously the answer is false, and we need to give one counter example. Here, one of the counter example, they give it to you. Sum of the interior angle of a pentagon is 540 degrees. So that's why this statement is false. Okay, the next one, some prime number are even number. So now we can list out prime number first. 2, 5, 7, 2, 3, 5, 7, and then 11, and then something, right? So basically, this statement here, some prime number are even number. True or false? Yes, because 2 is a prime number, so that's why the answer is true. Okay, the next example, write the mathematical statement requested in the bracket for each of the following, and then determine the truth value of each statement written. If it is false, give one counter example to support your answer. First of all, what we need to do is we need to create the statement first. Let's say they will ask us to create the converse for the statement. Create converse. If they ask us to create negation, then create negation. So now, for the first question, all multiple of 10 are multiple of 2. We want to create the negation statement for this statement A, right? So what we can do is we can put not all multiple are 10s are multiple of 2. So the answer here, we check whether it is false or not. The answer is false because all multiple of 10, which is can be 10, 20, 30, 40, are divisible by 2. We can divide by 2 all of them. 10 divided by 2 is equal to 5, 20 divided by 2 equal to 10, 30 divided by 2 equal to 15, 40 divided by 2 we get 20. So the answer is false. Then we give the counter example. Also the same for this one. They ask us to change the statement into converse. So if x greater than 5, then x greater than 3. So now we change, if x greater than 3, then x is greater than 5. If x is greater than 3, let's say we just put any value, which is here we put 4. Greater than 3, but 4 is greater, it is less than this one. 4 is greater than 5. I make a mistake here. Okay, wait. Let's say x, we just let x equal to 4. So here, if x is greater than 3, which is 4 is greater than 3, it is true, then 4 is greater than 5. True or false? Wrong, right? It is 4 less than 5. So that's why your answer is false. Okay, the next one, if x is a root of x3 minus 1 equal to 0, then x equal to 1. So we need to inverse this. So if you remember what is inverse, it is actually the negation of a statement, which is if negation of p, then negation of q. So here you have if x is a root of x to the power of 3 minus 1 is equal to 0, then negate it, which is x is not a root of x cubed minus 1 equal to 0. Then we want to negate it also, this guy. We put x is not equal to 1. So the answer is true, because both of them are true answer. True statement. And then the next one, we have if k square greater than 0, then k is greater than 0. This one we want to change to contrapositive, so change it, you're gonna get this. And then it is false because the statement is not true. Now we're gonna go through argument. First, we have the process of making a conclusion based on the statement. So first we have argumentation. Okay, this argument can consist of several premises and also one conclusion. So basically you can have more than one premise, and also you can have one conclusion at the end. So we have two types of statement. The first one is that specific statement, which is referred to a particular case, a general statement which describe a concept. So when we let's say we change from general statement to specific statement, we use deductive argument, which is a process of making a specific conclusion based on general conclusion. So from general we change to specific statement, we call it as deductive argument. From specific statement we change to general statement, we call it as inductive argument. Okay, go through example. Determine whether each argument below is a deductive argument of an or an inductive argument. So basically here they give you all acute angle are less than 90. Okay, this one is our premise 1. Okay, and then here they inform you angle PQR is an acute angle. This angle PQR is less than 90%. So this is your conclusion. So if you look at here, it is actually a deductive argument. Why? Because a general statement, which is this one, a general statement is transformed into a specific statement. So that's why it is under the deductive argument. Okay, now the next one, sum of exterior angles of a triangle is 360 degree, and the sum of exterior angle of quadrilateral is 360. Sum of exterior angle of a pentagon is 360. So basically this is your premise 1, and here they inform you the conclusion where the sum of exterior angle for each polygon is 360. So this is your conclusion for this one, premise 1, this one, conclusion. So basically if you look at here, it is very specific. Why they inform you here the triangle of the sum of exterior angle of triangle is 360. That's why it is specific. So now the conclusion, if you look at here, sum of exterior angle of each polygon, which we don't know what type of polygon is it. It is a general statement. So that's why from specific to general statement, it is used. They use inductive argument. Okay, the next one. How to determine and justify the validity of a deductive argument and determine whether the valid argument is sound. Okay, the first one. A deductive argument is said to be valid. This one, deductive argument will be valid if all premises are true. All premises are true. This one will be valid. So let's say we have the first question, the first form here, when all A are B, so that means in premise 2 we have C is A, so C is, the conclusion will be C is B. So if you go through this example, all actresses are good at dancing. So here Jasmine is an actress, Jasmine is good at dancing. So if you look at it here, all actresses is representing our A statement, are good at dancing is our B statement. So C is Jasmine and an actresses is our statement for A. So that's why when we want to create the conclusion, we combine Jasmine is good at dancing, so which is C is B. So now we want to know whether it is valid argument or not. So how to know whether the argument is valid or not? We need to go through this definition, which is all premise must be true and valid. So the first premise, premise 1, all actresses are good at dancing. True or false? False, because some actresses might not good at dancing. Jasmine is an actress. Yes, true. Jasmine is good at dancing. Yes, true. But the thing is, here all premise must be true, right? So that's why it is actually a valid argument. Oh, sorry, yeah. This part, I'm a bit confused. So that's why here it is valid but unsound. Why? Because the first premise is false. It is a valid one, but the first premise is false, so that's why we call it as unsound. Now the next one, we go through another example here. So since we have three forms, right? The first form that we learned just now is if all A are B, and the second form is if P then Q, if P then Q also. So this is the second form, and then the third form. Now we go to the next one. Example, are the following argument valid and sound? If not, please justify your answer. Okay, the first premise, all multiple of 16 are even number. True or false? Yes, true. 64 is multiple of 16. Yes, it is true. And 64 is an even number. Yes, it is true. So that's why it is valid and sound. Okay, the next one, all basketball are in spherical shape. Yes, true. The earth is in spherical shape. Yes, it is true. The earth is a basketball. Of course, false. So that's why here it is not valid, because the conclusion are false, and obviously it is not sound. The next one, form a valid deductive argument for a situation. Okay, so they give us one situation here, the first question and second question. All mammals are warm-blooded. Cats are mammal. Cat are warm-blooded. So we want to form a deductive argument. That means we will create premise 1, premise 2 and conclusion. So here is our premise 1. Cat are mammals is our premise 2, and cat are warm-blooded is our conclusion. Okay, the next one. If x is greater than 0, then x has positive value. If 6 is greater than 0.6 has a positive value. So now basically this is coming from the form 2. This one. So that's why here, if x is greater than 0, which is our premise 1, then x has positive value. So this is our premise 1 now, premise 1. And then 6 is greater than 0.6 is our premise 2. And here 6 has a positive value is our conclusion. Okay, another example. Write a conclusion for the following deductive argument to form a valid and sound deductive argument. Okay, the first one, all whole number are real number. Yes. 38 is a whole number. Yes, so now we want to create a conclusion. So whole number are real number. All A is B. Here C is A. So that means this part, it is C is B. So which is 38 is a real number. Okay, form a valid deductive argument for the situation. Write the premise for each of the following deductive argument to form a valid and sound deductive argument. So basically here they didn't give us this answer first lah. They just want us to fill in the premise 1 while they give us these two premise, which is premise 2 and also conclusion. So they give us 37 is prime number. 37 has only 2 factors. So here they use form 1. So 37 is our C is A, and then here C is B. So basically for when we want to create the premise 1, A, all A is B. So basically all prime number is B, has only 2 factors. Okay, the next one, they give us if the annual sales of A and C exceed the 3 million, then the employee get a bonus month of salary. So that means here, if the annual sale of the A and C exceed 3 million, which is our P, then the employee get a bonus of 3 month salary, which is our Q. So now they didn't give us the premise 2 yet. They give us the conclusion. The conclusion, they say the annual sales of the company does not exceed the 3 million. So here it is our negation for P, right? So that's why here will be your negation of Q, which is the employee of A and C do not get a bonus of 3 months salary. Okay, now we want to determine and justify the strength of inductive argument and determine whether the strong argument in the cogent. So basically, the inductive argument, you're going to have two conclusions. Either conclusion is true or either conclusion is false. So let's say conclusion is false. That means your argument is weak and obviously it will be not cogent. But let's say your conclusion is true. So your inductive argument will be a strong argument. So depend on this one, depend whether how to say whether it is cogent or not cogent. It is cogent when all the premise are true. So since we have premise 1, premise 2 and conclusion, right? So make sure all of these true first, then you're gonna get a cogent statement, a cogent argument. Let's say all premise are false. So here your argument is not cogent, even though the statement, the conclusion is true. Okay, the next question, the next example, determine whether the given argument are strong or weak. Determine whether strong argument is cogent or not cogent. Justify answer. The first one, the chairs in living room are red. Yes, true. Chairs in living room are red. Also true statement. Chairs in living room are red. Chairs in living room are red. So here, all chairs in the house are red. True or false? All chair. Nope, right? So the answer is no. So since the conclusion is false, then your argument is weak and not cogent because the premise are true, the conclusion probably false. Okay, the next one, we have the premise one, 27 is a multiple of 3 and 81 is a multiple of 3. So this one, is it true or false? Yes, it is true. 81 is multiple of 3, it is true. Or multiple of 9 are multiple of 3. True or false? It is true. So that's why this argument is strong and cogent because all the premise and conclusion are true. Okay, now we will go to the next part, which is form a strong inductive argument of a certain situation. So here we have a strong and cogent inductive argument depends on true premise and conclusion. These given premise are the evidence or the support to the conclusion made. Inductive reasoning can be carried out in the following steps. The first, observe some example or specific situation. Second one, observe the common features. The third one, make a general conclusion. Okay, first one. Form a strong inductive conclusion for each of the following number sequences. You have the sequences 1, 3, 5 and 7. So basically 1, 3, 5 or 7 they give to you. It is made up of 2 times 0 plus 1. 3 is equal to 2 times 1 plus 1. 5 is equal to 2 times 2 plus 1. 7 is equal to 2 plus 3 times plus 1, right? So when we do conclusion for this one, it is actually made up of 2 times n plus 1, where n is equal to 0, starting from 0, 1, 2, 3. So this is your conclusion. What about the next one? Sequence of 0 0.5, 0 0.25, 0 0.125, 0 0.625. Then they give you this sequence. So basically here, when we want to change into a strong inductive conclusion, you can use the variable n to represent the different value here. So 0 0.5 is equal to 0 0.5. Oh, sorry. The answer will be 0 0.5 to the power of n, where n is equal to, starting from 1 until 4, 1, 2, 3, 4, like that. So this is the answer. Okay, now the summary of, so now we just finished for this topic where we already demonstrate basic knowledge of statement and argument. Also, we understand the statement and argument. We apply the understanding of deductive argument and inductive argument in order to perform simple tasks. And we also already apply the knowledge of skill of logical reasoning. Okay, end of this topic. Thank you.